Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help teach you how to find the sum of a finite number of series for a arithmetic type of series. So what we're going to do here, we're going to take a look at this. We're going to try to calculate the sum from I equals 1 to 10 of this expression, 2i plus 3. Now, there's a couple ways to do this. Method number one, we could use what I would just call brute force. We could put in I equals 1, get a value. In fact, I'll start doing that. 5 plus, then we can put in I equals 2 times 2 is 4, plus 3 is 7, plus, put in I equals 3, it's going to give me 6, plus 3 is 9, plus, and this is going to keep going. Now, we could go all the way to putting in 10, and we're going to have, let's see, 2 times 10, which is 20, plus 3, 23. Is going to be the last term. But rather than writing this all out and summing them, what I'm going to do is I'm going to use the fact that when we have a series or a sequence, the sum of that sequence over n terms is given by n over 2 times a1 plus a sub n here. And here what we have our we have a series written out, and I just want to point out, what that series kind of looks like. If I were to make a formula for it, a sub n is equal to 5 plus, notice to get from here to here, we're adding 2. Here to here, we're adding 2. Here to here, we're adding 2. So this can be written as 5 plus 2 times n minus 1. Now, if we get to the very last term here, the a sub 10 would be equal to 5 plus 2 times 10 minus 1 is 9. 18 plus 5 is, there's your 23. So this sum is going to equal, let's see, n over 2, that's going to be, let's see, 10 over 2 times a1, which is 5, plus the a sub n, which is 23. I'll just go ahead and calculate a value here. Let's see, and I get 140 out of that. So that's what that sum should equal. I'm going to go ahead and just pause this, write up another example, and be right back. All right, folks, I'm back. So we're going to take a look at this guy, the sum from n equals 1 to 16 of 1/2 n minus 1. Now, the first thing I'm going to do here is I'm going to write some values out. And if you don't mind, I'm going to write it like this. The first one is going to be negative 1 plus 1/2. Then the next value is going to be, putting in a 2 here, we're going to have negative 1 plus 2 times negative 1. So that was the first value, and then here's the second value. And then the third value, putting in n equals 3, we're going to have negative 1 plus 3/2. Now, this first value here is going to be minus 1/2. The next value is going to be 0. The next value is going to be 1/2 plus, etc. This is going to go on and on for 16 terms. Now you'll notice here what we got is, this is the a1 term. You notice getting from here to here, we're adding 1/2. That's our difference. And then when we go from here to here, we're adding 1/2, and so forth. So this is an arithmetic sequence. So the a sub n is going to equal a1 plus the difference. And actually, let me go back and write that a1. Let me rewrite that. Oops. So our a sub n is going to equal our a1 term, minus 1/2, plus the difference was 1/2, like minus 1/2 to 0, we're adding 1/2, times n minus 1. So this formula should give all the values out to some value n here. 16 should be minus 1/2 plus 1/2 times 15. Give me a moment here. And I get 7 out of that. So this sum should be equal to, let's see, n over 2 would be 16 over 2 times a1 A1 is minus 1/2 plus A sub n evaluated at 16. And I get 52 out of that. All right, so I'm going to now take a moment here and pause this, write up another example, go through one more, and probably call that a day for this video. So hang loose for a moment, please. All right, folks, I'm back. All right, so we're going to work on the sum from n equals 1 to 16 of this expression, 1 minus 2n. Now, if you don't mind, I'm going to write out a few terms here before I get going. I always write out some terms when I'm dealing with these types of sequences, and I think that having the terms in front of you really is an important thing. So, all right, putting in n equals 1, we're going to have, and I'm going to write this out, 1 minus 2 times 1 plus, next term, putting in n equals 2, we're going to have 1 minus 2 times 2 plus, next term, putting in n equals 3. The next term is going to be 1 minus 2 times 3, and this is going to keep going here until the last term here. That last term is going to be 1 minus 2 times 16. Now, looking at these terms, all right, so this one right here is minus 1. This one right here, let's see, is 1 minus 4 is minus 3. And then this one is 1 minus 6, that's minus 5, and so forth. So what we're looking at here is an arithmetic term, or series, to get from here to here. Look at what's happening. When we go from here to here, we're adding negative 2. And from here to here, we're adding negative 2, and so forth. So this, oops, that's not what I wanted. So the a sub n here can be described by our starting point, negative 1, plus our difference, which is negative 2 times the quantity n minus 1. And you're probably getting tired of me saying this, but this is true starting at n equals 1. If you started at n equals 0, you would just have an n here, and that's it. And then the sum will equal n over 2, which is 16 over 2, times a1 plus the a sub n term. And that's going to be that very last term here. I haven't calculated that. Let me do that off to the side. A16 is equal to 1 minus 2 times 16. That's minus 32. Let's see, 1 minus 32, minus 31. And running a value here. All right, I get negative 256 out of this. All right, so I think what I'm going to do here is stop that right there and just call this a day. I think this video is long enough at the point that we're at. Again, the purpose of this video is to demonstrate how to find the sum of these sequences. And what I like to do is write some out, make sure I'm very clear I know what the a1 is, make sure I know what the a sub n is, and then the sum is equal to, n over 2 times the quantity a1 plus a sub n. Hope that this helps. Have a great day.